I need to record them. As I was telling you earlier on, like when we started kinematics, I said, when we started the graphs actually, I said most of the past papers actually required you to draw a graph. The only year when you weren't, actually it was 2 years, 2014 and 2021, you weren't required to draw any graphs. But all other years, you had to draw the graph, whether it was a speed time graph, velocity time graph, distance time graph, or displacement time graph. They gave you information, just like here. So a tiny, tiny paragraph with information. And then you need to take that information and use the graph paper that they gave you at the end to plot your graph. The good thing is you didn't have to come up with a scale because for all of the years, they actually gave you a scale already. So that was nice. But you actually needed to understand what's going on based on this information in order to know what that graph looks like, right? After class, please post the PowerPoint. Yes, because we finished with this, I would actually post the PowerPoint. And these questions, all these kinematics questions, I actually did them. I wrote the solutions for all of them, explaining each step. And I did each step by step. That doesn't even make sense. Anyways, I did the solutions for all the kinematics questions, the graph, explain what exactly you need to write in order to get all of the marks of the question. But I'll talk to you about that after. You need to practice sketching. Well, not sketching. Sketching and drawing or plotting a graph, two completely different things, right? Sketching is not to scale, meaning I can just draw this, show them the general shape of the graph. So let's say it looks like, well, obviously it's not gonna look like that. Let's say it looks like this. That's sketching, just showing them the general shape of the graph. They did not ask you to sketch, they said to draw. This is not to scale. I don't have a scale saying on the x-axis, this represents so and so, and on the y, this represents so and so. That's the difference between sketching and drawing. Sketching is just this little thing in the corner here. Drawing, you need a scale, you need to plot all the points accurately. Right. They ask you to draw, not to sketch. There's a difference. I am going to sketch what this graph looks like, but you need to practice how to draw the graph. So by me sketching it, you'll have a general idea of how your graph should look. And please practice drawing them. It's kind of difficult to do that with you because, you know, we're not in person. So I can't actually see what you're doing. But whenever you decide to actually practice this on your own, when I say practice, I mean actually drawing the graph with the scale on a graph page, you could always send it to me. But this is just the general shape of the graph. When you take all this information and plot it on the graph page, this is what the shape should look like. Let's start. A particle starts from rest and accelerates uniformly. A particle starts from rest, meaning that velocity, okay, hold on. Before we jump all the way into that. V time. So you should label your axes whenever you're drawing the graph. The Y is velocity, because they told me it's a velocity time graph. T is time. The first phase, that's what we call it, right? There are different phases of the graph. Let me just draw a little. Let's say the graph looks like this. This right here. This is the first phase of the graph. We call it a phase, like I just said. So let's just pretend that's a straight line. This red part is the first phase of the graph. This pink one will be the second phase. The blue one is the third. That's the same color, that doesn't make sense. But anyways, the third one is the blue one is the third phase, and then this purple would be considered my fourth phase. So I'll talk to you after about the solutions that I have, right? That I did. Okay, so we call them phases, and it helps to break up all the information that they gave you into different phases. It would help you to plot the graph. So my first phase would actually be this first sentence here. Particle starts from rest. At rest, I know velocity is equal to 0. So I'm starting here, and t is equal to 0. So at rest, velocity is 0, t is equal to 0. So I know for a fact I'm starting here. And accelerates uniformly to 20 meters per second. So I know I'm stopping at 20 meters per second. Oh, you have to put your units then. Meters per second. Right. Accelerates uniformly to 20 meters per second. So I know I'm starting at 0 and I have to end up at 20. But what exactly would that look like? Is it a straight line along the x-axis? Is it a horizontal line? That doesn't make sense. What does it look like? Well, accelerates uniformly. I said when you see the word uniform, it means constant acceleration. From the key features of a velocity time graph, we know that acceleration is actually the gradient of a velocity time graph. They told me that acceleration is constant or it's uniform, meaning that this has to be a straight line from my initial point to 20. That's how I know the shape of that. That's how I know what's going on here. It's a straight line. And they told me in 5 seconds. So that means at this point right here, t is 5. Here is 0 and there is 5. It took me 5 seconds to go from 0 meters per second to 20 meters per second. So that's my first phase. What's the second phase? They told me it continues at a velocity at this velocity for 10 seconds. It continues at this velocity, meaning the 20 meters per second, right? If it stays, if my velocity does not change, it remains at 20 meters per second. That means that I have a constant velocity. Back to the key features of a velocity time graph. If you have a constant velocity, what does that look like? If my velocity does not change, it stays at 20. What does that look like? It's a horizontal line. And how long did this go on for? How long did I stay at 20 meters per second? For 10 seconds. So from this 5 mark position to whenever, it took me 10 seconds. So here, t is actually 15. Between this point here and this point here, it took me 10 seconds. So 10 plus 5 is 15. That's my 15 second mark. Do you understand that? Please let me know if you're following or if you're confused. Are you following so far?
Yes, miss.
Okay. Next phase. It then accelerates again uniformly to a velocity of 60 meters per second. So it accelerates again. Okay, I can do that. Accelerates again uniformly. Accelerates meaning that, so we know acceleration is the gradient of the thing, right? Uniformly meaning that it's a constant acceleration, so I'm looking at a straight line. But is my line going uphill or is it going downhill? Well, the answer is uphill because it goes from 20 to 60, right? What color is this? Is pink? I'm not sure. So it goes like this. Let me just extend this. On this point here is That was my third phase. Oh, and they told me in 5 seconds. So from this 15-second mark to whatever the point, it took me 5 seconds. So it took me 5 seconds to go from here to up here. 15 plus 5. Let me use the finger. It took me 5 seconds to go from this point to this point. So 15 plus 5, this is 20, would be right here. But there's another phase. The particle then decelerates uniformly until it comes to rest 15 seconds later. Decelerate, that's a negative acceleration, right? Negative acceleration means that my gradient has to be negative. What does that look like? If the gradient is negative, I know it's a straight line, right? Because they said uniformly. But is my line going to look like this, or is it like this? Well, because they told me decelerate, it's a negative acceleration. Negative acceleration means that my gradient has to be negative. If the gradient of a line is negative, we know that the slope has to go downwards like this. So that's why my fourth phase would actually look, let me use a different color, yellow, like this. How long did it take me? Well, from this point to this point, oh, they said it comes to rest, right? Remember, rest, velocity is equal to 0. So it goes back to this point, to the x-axis where my velocity is 0. It goes back here. How long did it take me from this point to this point? They said 15 seconds. So 20 plus 15. This mark here is 35. Everybody good with that? That's just what your graph should look like when you actually draw it to scale. Are you good with that? Yes or no? Yes. Okay, what about the other people? Okay. Javid, Troy, what's going on? Are you alive? Yes, Troy. I get you on this, I guess. I guess. Okay. Well, yes. Make sure to note this. This is just a sketch. This is a sketch. It's not trying to scale. Okay? But this is the general. This is how your graph should look. Should look something like this. If it does not look like that, something's wrong. It's easy. It really is. It really is. Okay. And it's 3 marks, eh? Only 3 marks. Anyways, from your graph, this is why it's important to know how to read a graph. From your graph, determine the total distance in meters traveled by the particle. For these questions, it's always important for you to note what type of graph are you dealing with. We are dealing with a velocity time graph. That's why I had key features for you, all the key features that you need to know about each graph. So because this is a velocity time graph, and they want me to find total distance, I know that to find the total distance, it's the area under my velocity time graph. That's why it's important to know the key features, right? Once you know what type of graph you're dealing with, you go back to the key features. They want you to find total distance. You know that that would be the area under my velocity time graph. They want total distance, meaning the distance under, well, the area under this entire graph. There's a problem though. If you look at this entire graph, this shape does not look familiar to you. You do not have a formula to find the area of this shape, but that's okay because you could split it up into different shapes, ones that you know formulas to find the areas for, right? Okay, so I can see this is a triangle. I know how to find the area of a triangle, so that's okay. This is a rectangle. I know how to find the area of that. This is a trapezium. I also know how to find the area of this. And then this again is a triangle. Easy. Find the area for each one of these sections, add them, that is your total distance. That is it. Okay? Let's see. Can you try this for me? Can you try to find the total distance and let me know what your answer is? Just find the area of each of these shapes. So the triangle, the rectangle, the trapezium, and then this other triangle. Add them and tell me what your answer is. Anybody has an answer yet? To me privately or to everyone, doesn't matter, right? But I'm gonna go through it now. So I want the total distance. The problem is I don't have a formula to find the area of this shape, but I can split it up into different shapes that I know how to find the areas of, right? So this is a triangle, rectangle, trapezium, and another triangle. So looking at the area of the first triangle, I know that the area of a triangle is base by height. Base by height on 2, so base by height divided by 2. Or some people say a half base by height. Doesn't matter, right? Let me just call this area A1, A2, A3, A4. So I need to find all of these areas, 1, 2, 3, and 4, add them, that's how I get my total distance. So looking at A1, A1 is a triangle. So the formula I'm using is a half base by height. What's the base of my triangle? Well, 0 to 5, that's going to give me a 5. And then the height from 0 to 20, that's 20. Substitute those values. A half base is 5 by height, which is 20. 20 by 5 is 100, and 100 multiplied by a half is going to give me 50. 50 meters. That's the distance in the first 5 seconds. The distance covered in the first 5 seconds. I want A2 now. What shape is A2? A2 is a rectangle. What's the area of a rectangle? Length by breadth, or you might say length by width, doesn't matter. What's my length? So the longer side, I'll say that's 20. So from 0 to 20. So this length and this length, that's 20. Breadth or width from 0 to 5, so that's 10. 20 plus 10, that's 200 meters. So the distance covered from 5 seconds to 15 seconds is 200 meters. Next one, A3. What shape is that? Trapezium. What's the area of a trapezium? It's a half by the sum of the parallel sides multiplied by the perpendicular height. Substituting values, that's a half multiplied by my parallel sides. I'm looking at this and this. The length of this is 20. This entire length goes from 0 to 60, so that's 60. And then the perpendicular height would be this, and that's 5. +20 plus 60, that's 80. 80 times 5, that's 400, and then 400 by a half is 200 meters. So between 15 seconds and 20 seconds, I cover the distance of 200 meters. Last one, A4. What shape is that? It's a triangle, a half base by height. That's what I'm using. So half, my base is from here to here. That's 15. 35 minus 1 is 15. Times the height, which would be from here to here. That's 60. Fifteen times 60, that's 900. 900 by a half is 450. So now I know the distance traveled for each one of these. For A1, it's 50. A2, so from here to here, it's 200. A3, from here to here, it's also 200. And then for A4, from here to here, it's 450. So if I want the total distance, meaning from this point, my starting point, to where I end, I have to add all of the distances that I just calculated, which will give me 50 plus 200 plus another 200 plus 450. This would give me 900 meters. That's the answer, 900. Everybody good with that?
Yes, miss.
Nice.
Yes, miss. This is
Cool. Who didn't answer me? Javed, Jano. You good? Okay, nice. Cool. Next one. Wait, was anybody taking that down? Was trying to integrate to see if, okay. Okay, interesting. if you said you're trying to integrate, what exactly were you integrating to get the total distance? You said you're trying to integrate, so what are you integrating? Post in the WhatsApp group, please. The equation of each line. So the graph look like this. You found the equation for each line. So I'm gonna have multiple operations to do. Okay. 20. And that's a 20. Oh my, that's a 5. This was 15. Hold on. This was 20. And this was 35. So how did you find the equation for each line? You took 2 points from the gradient, from the constant, and then you said y is equal to whatever. Okay. So let me do this, right? So this is 25. 20 okay, well that's 4. Anyways. 4. Y is equal to mx plus c. But this is through the origin, so y is equal to 4x. Y is equal to 4x. In theory, integration should work, right? Hold on. So you got the equation of the first line. You got y is equal to 4x. Okay. Then what did you plan on integrating to get distance? This equation, the 4x. I know you said you abandoned it. 4x, which is for t, because the value of t, the value of x is t. Y is equal to 40. Y is really v in this case. V is equal to 40. So to find s, you said the integral of v with respect to time. So the integral of 40 dt, and you got 2t squared. Now we get area of design only. But that would give area of that line only of the first triangle, right? Which was 50. Because t is 5, 5 squared is 25, and that's 50. Technically, this is not, well, let me not say technically it's not wrong. It's not wrong, but very time consuming. No, right? It's not wrong. Yeah, don't do that in the exam. It would take you way too long and you're gonna waste time, especially for a 4-mark question. No way, don't do that. But it's not wrong. Just very, very time consuming. Okay. B. Average velocity. Can anybody tell me what's the formula to find average velocity? It was one of the formulae you were required to know. Displacement on time. Okay, well, it's a change in displacement on time, but yeah, same thing, right? The average velocity of the particle. So average velocity is a change in displacement on time. Average B, change in displacement on time, right? So they want for the entire journey. So we said the total distance covered was 900. And the time taken to cover this 900 meters was 35. Can anybody tell me what answer they got here? What's the average velocity? Okay, no answers. That's cool. 25. Well, you can leave it as a mixed number. Don't forget your units, meters per second. Or put it as an improper fraction, which is 1/87 meters per second. Don't put the decimal because that's not really an accurate answer. It's best to just leave it as a fraction. So the mixed fraction or the improper fraction, either one will work. Everybody good with that?
Yes, miss.
Counts we use significant figures. Like I said, technically it's okay. But using, let's say using a decimal, and you put it to 3 significant figures, that's technically not the most accurate answer. So I mean, you could put it, but make sure that you also include the fraction, whether it's 25 and 5/7 or 180 and 7, because this is the exact value, meaning this is the most accurate answer. So if you want to put it to 3 significant figures, go ahead, but make sure you put this, because this is the exact value. Okay. A particle travels in a straight line to this. A particle travels in a straight line in such a way that after t seconds, its velocity v from a fixed point O is given by the function v is equal to 3t squared minus 18t plus 15. See this? See, when you're given a equation, that's when you know most likely calculus has to come in somewhere. Let's look at what they want us to find. The values of t when the particle is instantaneously at rest. At rest. When you see rest, if a particle, a body, object is at rest, we know velocity is equal to 0. And therefore I need to put this entire equation equal to 0. I'm just going to talk it out because time is up, so I can't do it right now, but I'll just talk it out, right? So that's what you're doing for this first part. Put the equation equal to 0, find the values of t.